Hey Motorsynth, Ilja, it's lovely to see you again, all sporting the lovely red ties.
Yes.
Yeah, so I remember when Motorsynth came out, everybody was really wowed by it, and you've got a new version, right?
Yeah, that's it. So the original launch of the Motorsynth happened here at Superbooth, but it was 3 years ago, at 2019. That is when we brought the first few prototypes of this idea to life, and we wanted to just bring it here and get some feedback and get some, attention. So it's been 3 years. In this time, we've managed to actually bring that idea to manufacturing, and we managed to send out somewhere around 450 original Motorsynths.
Oh, nice.
And based on that feedback and that experience with manufacturing and dealing with all the, issues, because it's a complicated, it's a, technological challenge, this device. It is an electromechanical synthesizer. So in these 3 years, we've learned a lot of good lessons, valuable lessons, and collected all the feedback. So we've made some improvements to the original design. So that's why, we were a little bit shy to call this Motorsynth 2, or whatever. So we decided to go with Mark II, which means the second iteration of an idea. But the core idea remains the same. We wanted to build a synthesizer that is completely different from anything else, and this whole system is based on this idea of using electromotors as oscillators, because when you think about it, electromotors are oscillators, but only they have a rotating movement. So these are brushless DC electromotors, and they are conventionally used for flying drones, right? So they are very durable, they're very fast, and
they got very quick response time as well.
Very quick response time, yes. And then we were playing around with those drone motors, and we realized, you could probably even tune them to musical perfection, right? So, and this idea, thanks to this initial spark, we hired a very knowledgeable person from Riga, which is our home city, who has a lot of experience with motors, and we developed our own motor drivers, and eventually, since 2019, we've also come to develop our own customized electromotor model. We've partnered up with one of the larger manufacturers, and we have our own custom motor model. So when motors spin, they produce electromagnetic fluctuations. It's that old guitar trick when you take an electric drill and put it next to your guitar pickups, then you get the induction noise. So here we're using small inductors that are mounted next to the coil bit of the rotating coils of each motor. The synth has 8 motors, and they are split up in 2 motor voices. That means it's a 4-note polyphonic synth with 2 motor voices. And the previous version of Motorsynth had 1 filter section for both voices. This Mark II version has a separate multimode analog filter for each motor voice.
Right.
And also each motor voice has a analog amp envelope with for every note, polyphonic amp envelope.
Right.
Yeah. So that is something that we did to increase headroom possibilities and drive possibilities, and also it allows you to have 2 independent sets of settings for both motor voices. Right. And I forgot to mention that, the core idea stems from this idea of collecting the induction, but also there are these motors are equipped with so-called optical discs, which is an idea that we created for this. So they are reflective aluminum discs, and each disc contains 3 wave-shape tracks.
Right, so you can change effectively the oscillator.
So they have 3 preset wave shapes. For example, the one in the middle here is so-called, let's call it optical square wave, because there's an infrared beam of light that's being shined onto the disc from below, and as it spins, that track absorbs it or reflects it, thus creating a kind of unusual...
I think we should hear it. Let's hear what it is.
That's it. All right, so let's start with one motor voice, right? So I'm latching it. When I switch the scale, right, it starts spinning. It revs up to reach like an octave up interval.
Right. Oh, it's nice down there, isn't it?
Yeah, it's really good. It's easier for a motor to spin slowly as well. So here we're listening to one of the optical waveforms. I'm just going to switch around a little bit. Sine, saw, then square, and this is the inductive wave. The inductive wave is the noisiest one, the grittiest one. And now we can apply the standard synth, synth logic to it. So I'm going to switch the ARP on, make it a little bit slower. So first of all comes the envelope, amp envelope. Okay, I'm going to blend in the second voice, lower one. So I'm going to give the upper voice a decay. Okay, now there's a filter section. Right now it's linked. That means that the voice 1, voice 2, and the digital voice. Yeah, I forgot to mention that we've added a digital voice.
Oh, okay.
So let me just bring that in. So digital voice is good because it offers like.
It's cleaner, isn't it? Because
it's a little bit cleaner,
it's
more stable.
It's a pleasing but dirty sound.
Yeah, yeah. But together you can get results that you can do like pulse width for each traditional wave shape, and you can also use it as a noise source. For example, like here. So I'm using it as a noise source here. But let's go back to something else.
Is that cycling through the voices when it's changing pitch, or is it actually moving the pitch of each individual disc? Because there's no lag there, is there?
Yeah, when you're in ARP mode, it already knows ahead of time which note it should play, so it keeps those discs spinning in the correct.
Okay, yeah.
So there's lots of optimization going on.
Right, makes sense.
If you were to plug in a keyboard and you went like this, like boom, 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 la la la, then
you get slide.
Yeah, you will get some kind of slide. So yeah, I'm going to reduce this volume a little bit. So just finish a few things to say, and then I'll just play you out. Okay? So it has three fully independent voices. Like you have two independent multimode analog filters for each motor voice, independent portamento sections as well, independent amp envelopes. But everything also can be just linked, so it's the same. So it works in concert. You have three assignable LFOs that can be assigned to. Each one can be assigned to two slots on the synth, which can be literally almost any parameter on the synth. And each LFO can have a different clock source, a different clock subdivision. And also you can modulate, you can use the input nodes or each other as cross-modulating LFOs. It has 8 motion record lanes, but this might, so we might add more. And also it has an arpeggio that you're hearing right now, and the built-in sequencer, which right now is in an unfinished state right now, but we're still a few months away from production. So I'm going to just play you out, and as I do, I'm going to use the drift and cross-mod effects, which are the effects that can be achieved like naturally within the synth. So this is the drift. Cross mod, modding the synth's entire amp output with the frequency of voice 1. Or with voice 2. assigned. I'm gonna assign this to the frequency of voice 1. Also, we have this really cool thing called clutch. We invented this for the Motorsynth because we thought it's like a cool pun or something.
Yeah.
But I think every synth should have a clutch function. Clutch means that, like, press down clutch. Now I can change anything I like on the synth, but I don't hear it instantly. For example, remove the cross mod, make it louder, and when I release the clutch, all parameters step into action.
Sort of like an edit buffer, like a temporary edit buffer.
Exactly, yeah.
Nice.
I'll show you one preset and then we can go. Just a cleaner preset, because I got a little bit like carried away. You can shift all of them. Now I'm gonna put on some reverb from the light pedal. Some plasma drive.
Excellent.
I hope that was okay.
Yeah, so you said that you're still a little way off production on these. When are you expecting these to come to market?
We think that we can. We think we'll build the first few hundred this summer, but naturally it's unusual time right now due to supply issues all over the world, especially in this industry. But yeah, the plan right now is to build the first 200 or 300 this summer, and you know, if you follow us or if you follow, you know. If you follow us, then you'll be informed when the first round of orders will be active.
And what sort of price are you going for? Is it presumably a little more expensive?
Yeah, well, now we feel that this is more accomplished kind of instrument. So we're thinking about the €3,000 range right now.
Okay.
But that may change due to various reasons. So we're not
so it's hard to say,
announcing the final price just yet, but quite soon.
Thank you very much.
Thank you. Yeah, thanks for watching.